Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials on any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devops.school.
First of all, we will be talking about why we need Docker or legacy thing. Let's talk about legacy thing, like what all things are required. Yes,
Yeah, this is Sachin here. Let me interrupt you. So I missed the starting point. So may I know the which topic you are going to cover today?
Docker.
Okay, sure. Thanks.
Yep. So yep, guys. So first of all, we will be learning that if you want to develop one application, how you will be developing. We can assume that we are a developer, right? So what all things are required to develop an application? A small application, not a big enterprise level application, small application. We should have one computer, first of all. On top of computer, we'll be having our operating system. It could be anything, a Debian, Ubuntu, CentOS, or Red Hat, no matter, right? On top of our operating system, if it is a web-based application, then obviously we need to install a web server and the compiler. Let's say PHP we want to write, so PHP compiler is required. Then we'll be writing our code, all the binary library, configuration. We will be creating our application. We'll be keeping all this thing together. If you want to host your application to make it live, what we'll be doing? We will be copying our code on the server. Server will be having again operating systems, web server, compiler there, and then we'll be hosting our application. A simple way to make it live. How things are working in enterprise level of application here. So we can see that here, developers. Here I'm just writing, highlighting one developer guy. We can have multiple developers. So for an example, this developer developed his application on his laptop, right? Like, this is the computer of this guy. So he will be having his operating system on it, and PHP compiler and all the library binary. He will be configuring. Once code is tested from his end, like whenever he will feeling like, okay, that's the code, that is the requirement, that is done now. So he will be pushing that code to centralized code repository. It could be SVN or Git, and he will be informing to DevOps guy, or whoever is deploying that code to a respective environment, like prod, QA, UAT. They'll be informing to the team, the team, hello team, just deploy this code to your respective environment. So for an example, we will be having DevOps team. So DevOps team will be taking that code. This guy will be taking that code to his respective environment. It could be anything, right? So he deployed, and after some time, once application got deployed successfully, he started seeing some bugs, some error. What he will be doing? He will be again, he will be in touch with the developer guy. He will be informing to developer saying that, brother, I'm facing some issue. Can you please help me to resolve this? They will be doing some, a telephonic discussion. They will be again, they will be just, arranging some conf call, Skype call. They will be finding it out what is the issue, what was the issue. Finally, after spending some time, 1 hour, 2 hour, they are getting to know, like, the reason was that compiler version. Developer used latest version of compiler to create the code, and environment is having older version of compiler, right? So what DevOps guy should do, if you're working in any of the organization as a DevOps engineer, you might be having admin privileges. You can make changes in system, right? So what this DevOps guy should do while they are getting to the root cause, the root cause is just the compiler version. What do you think, guys? This DevOps guy should update this PHP version to 6.0 to 7.0, or this DevOps guy should tell to developer, like, downgrade your PHP version, your compiler version, and write code accordingly to that. Which is the best practice, guys? Any clue, any suggestions for me, guys? Yes.
Upgrading from version 6 to 7 on the prod environment with necessary permissions and change management and all of that.
Okay. What about others? Faizan, Habib, Sachin. Yeah, guys.
Yeah,
Yes, same.
upgrading. Yeah.
upgrading, right? So this is too bad actually. This guy should not update anything on the environment first of all. Why? Because there might be possibilities in environment, hundreds of application is already running, and those all application are based on PHP version 6.0. As soon as this guy is updating this version 6.0 to 7.0, what will happen? His application, this guy's application, the developer's current application will be started working, but older application might be having lots of trouble. They all stopped working because whenever any compiler is releasing with a new version, so lots of things they are deprecating or they are adding new features. So any of the code or functionality has been deprecated. So because of that, older application will be stopped working. There is a big acceleration can be happen because of this update. First of all, the second thing is that he might be losing his job because if it is a production environment, then lots of issue will be there. Whenever guys we want to update anything in our environment, we'll have to take lots of approval. Without approval we can't do that, right? Even for migration and all, it's a big thing. So DevOps guy will have to talk to developer saying that, brother, just downgrade your compiler version and write code accordingly to that, and then he will be again pushing, and then this DevOps guy will be deploying the code. How Docker is solving this situation here? Now Docker came in market. What Docker exactly is doing, how it is solving the situation, how it is helping us. So Docker says that, okay, you no need to install any web server on your environment. You no need to install any compiler on your environment. In even I don't need.
Hey viewers, our Mastery in DevOps engineering program can help you to hone the skills necessary to succeed in high-level DevOps positions. So what are you waiting for? Enroll now and earn certification that show you are keeping pace with today's technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Any of the operating system. I will be having my own operating system. Okay, so what is happening guys here is, see this thing carefully. So whenever we are talking about containers, so containers will be having their own operating system, their web server, compiler, all the configuration you'll be wrapping in form of container, and all you need to do is you need to take those container on your server wherever Docker engine is installed. Simply you'll be installing Docker engine in your environment, and you will be containerizing your application no matter what version of application, what version of your operating system is. Even different operating system will be supported, but the condition is applied here. This should be Linux Unix based operating system, right? Windows will not work here. And PHP compiler version, if it is 7.0, that is fine, there is no problem, your application will be working fine. Another application like they need PHP 6.0 or some older version, that is also fine because they will be having their own compiler installed inside the container. It is very similar to concept of your virtual machine. Okay, I will be making more clarity on those things. First of all, here each application will be containerized and those will be running inside the container, so they will not be able to communicate to each other. Each application will be running independently inside the container. How it is happening, what the feature, or what, give me a second guys. Sorry guys. So I will be talking about who is facilitating to these containers to provide memory and CPU and all those things we'll be learning now, right? So give me a second, I will be just taking my another PPT where we'll be discussing about these all things in very detail. So this is the PPT, and where is the other one? Drive. Got it. Here it is. So yes. So see that guys here. First of all, we will be learning. We'll be seeing comparison between virtualization and containerization. After that, we'll be seeing what Docker exactly is. Just to see, what exactly Docker is. It is, containerizing. It is allowing you to containerize your application, keep your application inside container, and deploy it on your environment. right? And architecture of Docker, and then hands-on. So let's compare virtualization and containerization. So guys, see this slide. Yeah, this is a slide. It is all about virtualization. First of all, I want to tell you there is two type of virtualization: type 1 and type 2. Type 1 virtualization will not be having installed on top of operating system. It will be having its own operating system, and type 1 will be installed directly on top of hardware. Type 2 hypervisor is nothing but example of your Oracle VirtualBox and VMware player. You need to have your own operating system, like I'm having Windows 11, and on top of this Windows I am having my hypervisor running it, VirtualBox, simply. And then we can create virtual machines. Each virtual machine will be having hardware resources allocated to them, like RAM and the CPU and hard drive space, virtual hard drive. So these resources will be allocated to each of the virtual machines, and they will be working fine. Like you can install your application, operating system, everything there. So for an example, just see here, whenever guys we are talking about virtualization, it means we are talking about hardware level virtualization. What it has been by hardware level virtualization? So whenever you'll be creating any virtual machine, you'll have to assign some amount of RAM or some CPUs and network configurations. So it will be virtualizing your hardware devices. Whenever you'll be creating a VM, and if you try to install any operating system inside the VM, it will be, your operating system be feeling like all those resources are independently available for this operating system. Once OS is installed, you can keep your, binary library, compiler, web server and all, and on top of this, you will be hosting your application. Now let's take an example. Here, each of this VM, I assigned 1 GB of the RAM, 1 GB to F1, 1 GB to F2, 1 GB to F3. Now, here F1 is running on 950 MB of the RAM. It needs more RAM. F2 is running only 100 MB of the RAM. It is utilizing 100 MB, and F3 is using only we can say 200 MB of the RAM. These two VMs are having lots of resources freely available. That if this F1 needs more RAM, so what do you think that it can ask for these two guys for assign or to allocate some RAM memory to me, right? Any clue on that, guys? Yes?
No.
No, it should not, right? Even if I still want to assign some amount of or increase the memory, then what I should do? I'll have to make it down, correct? If my VM is running, then I cannot make any changes over here. I'll have to make it down, and then I can increase decrease resources over here. Now what is happening inside the container? What is happening inside the container? Let's compare it with the container. Which slide I'll have to go? Here, containerization. So guys, see that on top of our host operating system, we'll have to install container engine. So first of all, Docker is not alone containerization tool. There is lots of another competitor of Dockers are available in market. The major one is Podman. Podman started beating it, and I don't think so it will do, but Podman is a product of Red Hat, so they are focusing more on Podman. Even today, after completion of the session, I'll talk few things about Podman so that you guys will be having very good understanding on that one as well. Okay, in one session we'll be seeing Podman as well, but our focus is just to learn Docker. So here guys, whenever we are creating container, we know it's not required to assign any amount of CPU, hard disk or memory to the containers. It is not required. Okay, containerization is nothing but operating system level virtualization. All the required resources will be provided to your container by your operating system. Operating system will be providing required resources to the containers. Now let's go to another slide. Here just I told you, like virtual machine we cannot increase decrease resources if it is required. Here we seen here in this example, left hand side, in case of virtual machine, you can see that this is my VM1, VM2, VM3. VM1 I allocated or assigned 6 GB of memory. Here it is using 4 GB of memory and 2 GB. It is freely available. Second VM, 4 GB I allocated overall to this VM. 3 GB it is in use.
Hey viewers, trying to get into DevSecOps? Enroll for our DevSecOps certified professional programs and earn the certification that shows you are fit for these technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
And 1 GB, it is freely available here. And again, third VM, 6 GB I allocated to this, and 2 GB is in use, 4 GB is freely allocated. Overall, we can see that it is using 9 GB of memory and 7 GB is waste memory. Nobody can use it, it is just there. So what is happening? In case of Docker, what happens is, as much as resources are required, only that resource will be utilized. Okay, it will be using only the required resources. Let's say, for an example, my container is currently using 4 GB of RAM. Now my container it is just cooled down and it is not requiring more resources, like now it is using only 2 GB of memory, and again it is going down slowly 2 GB and then 1 GB and 500 and 100 MB. So what it will do is, it will be releasing those memory for, or those resources for host machine. If any other container required more RAM, so host machine will be allocating that much of amount of memory, required memory, to the container. So here, in case of Docker containers, it will not be consuming your resource unnecessarily. Only the required resource will be utilized by your container. I hope you guys are getting it, whatever I'm telling you. Is it clear to you guys how things are going on here?
Yes.
Right. So let's go to another slide here. Again, the same thing, virtual machine will be having their own resources, binary library, operating system, and all those things. Your container will be having operating system as well. I'll tell you later on. A simple and a small comparison in between virtual machine and containerization. Size. If you want to install Ubuntu operating system in your virtual machine, minimum 8 GB is required. Minimum hard drive space is required 8 GB. You should have 8 GB there, right? VM will be starting very slowly. It will be performing post power on self test, then it will be searching for MBR, and it will be just searching for grub, and grub will be just going for init or systemd, and then targets, and then finally your operating system is getting started. It will take around 1 minute, 30 seconds to 1 minute, not more than that. Docker container. Containers will be very lightweight in size, 150 MB sometimes. Maximum of Ubuntu operating system, 150 MB. Startup, as soon as you are pressing enter key, your container will be up and running with its own operating system. Integration part is easy. Like if you want to orchestrate it, you want to take it to highly available environment, you want to do auto scaling and all, that is very easy in case of Docker containers, guys. Now we will be seeing that behind the scenes, who is providing resources to the Docker container. Like I need memory, I need hard drive space. What all things are in background, what all components are there, those are providing resources to the container. Okay, I'll have to update actually this diagram. Okay, to store your containers data, first of all, where your container is storing the data. Obviously we are not assigning any hard drive to the container, so obviously data will be stored on host machine itself. Okay, because this is operating system level virtualization, so operating system will be providing the resources, right? So basically we will be having overlaid 2 drivers, storage driver, that will be allowing our container to store the data. Okay, one more important thing here is, your data will be available inside container till containers live. If you are deleting the container, data will be deleted immediately. You cannot recover it back. Once data is deleted, it is gone. We are having few solutions to persist the data that I will be discussing in session. Namespaces, what exactly namespaces is? Our container will be having processes running in it. Okay, there is possibility similar processes, because this is operating system level virtualization, so there is possibility that similar processes are running on your host machine as well. So namespace will be isolating them, and it will be making like resources are dedicatedly available for that container only. Even similar processes running on your host machine, that will not be able to communicate to running process inside the container. But still whatever process running inside the container, you can list those process on host machine. I will show you practically. To enable networking, we are having few networking drivers or features available inside our Docker, so that multiple container can talk to each other, right? We will be discussing about networking, what type of networks are available inside Docker. C group. C group is a feature of your Docker. By using this, operating system will be allocating resources to the container, like, I need one CPU, I want to access, memory like 1 GB or 2 GB, and those resources will be allocated by C group to secure your container. SE Linux and SecCom is already there to provide them securities. Okay, so guys, let's see Docker architecture. What is the Docker architecture? This is the Docker architecture. So client and host and the registry. Registry I'll discuss later on. So whenever we'll be installing Docker, so these two things will be installed on your system, okay, on the server basically. So what will happen is, whenever you will be running any Docker command like Docker run, Docker ps, Docker images, any Docker related command, so those commands will be received by Docker client, and Docker host is nothing but a server, Docker server. Docker server will be taking action on it. For an example, you want to start a container by executing command called Docker run. That command will be received by Docker client and it will be sending to Docker server. Okay, so what server and daemon, both are the same thing. So what this daemon will be doing, it will be receiving the command and it will be checking, you want to start a container by using which image. First of all, daemon will be searching, okay, that image is locally available or not. If that image is locally available, container will be created immediately on your operating system. Okay, container will be created. If that image is not available, then
Hey viewers, are you looking for formal training on SRE practices? Take our SRE program. This course will teach you how to successfully implement site reliability engineering in the modern day 24/7 services. Kickstart your SRE training today. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
it will be going to hub.docker.com. This is a registry where all Docker images are available, and this is the default registry of Docker. So it will be going there, it will be pulling the image on local machine, and then container will be created. So always remember this thing, guys. Yes, anybody is having any question, queries? Okay, so always remember this thing, guys. Container will be getting created out of image. If you want to create a container, you should have an image. You can convert the running container to image as well. That I will be telling you in today's session only. So yes, guys, this is it. This was the theoretical part. Now I'll be moving to practical. If you guys are having any question, queries, please ask me. No question, queries? Shall I proceed for proceed, guys? Yes, guys. Shall I proceed?
Yes, sir.
Okay.
Yes.
AWS console login. I will be logging to AWS account. This one. That and then Z. Let's go to EC2 instance. I will be creating one EC2 instance. I hope all of you are aware of this, AWS. Yes, guys. I need input from you.
Yes.
Yes, Anish. We have already had that session.
Okay, then I can create here VM. So launch an instance. So basically, I will be choosing Ubuntu. I like to work with Ubuntu. These days, everywhere people are using Ubuntu. I will be just choosing T2 small. Add a storage. That is fine. Security group. So guys, here I will be just enabling all the ports, because in Docker container, whenever I'll be doing port mapping, it will be like, again and again, I'll have to go to security group to enable those ports. I don't want to do that. So I'm enabling all the ports. Launch instance. Yes, my instance is created over here. View instance. It is getting ready. Yes.
So this is Sachin here. So don't we have the separate Docker service on AWS cloud, or
Yeah,
we
we do
have
have
to install it
ECR.
on EC2, only EC2?
Yeah, I mean ECR, ECS, Elastic Container service is there. We can create
Okay,
containers
so
in AWS. Yeah.
okay, and here we are installing the Docker first on EC2, and then
Yes.
we'll create the
Then we
container.
will be correct. Yes. Why we are doing like this? ECS is not part of our course content, and the reason why ECS and ECR is not part of our container is like,
Mm-hmm.
we need to learn Docker build, image, how we can create image, correct? We will not be able to execute, commands over there, and we will have to see lots of things here, like, whenever you will be going to work in any of the project, they will not be giving you ECS and ECR, right? You should, or they will be giving you one server. On that server Linux machine, you'll have to containerize their application. And whenever we are containerizing any application, it is very easy to containerize it on Linux machines.
Okay.
Let's log in there. Here I am. Sudo su hyphen. Guys, I will be following steps from Docker documents. So install Docker on Ubuntu. Go here.
Anish, sorry to interrupt you. We will get that
Yes.
slides on which you were explaining, right?
Those was for theoretical part, right?
Yes, yeah. Both the theory as well as the steps that you follow.
Okay, so you want to say, like, whatever command I'm executing, I'll have to create document as well for that, those things. What I'll do is,
No, Anish, even if you have any document, if you share that, I think that should be fine.
definitely, I will be sharing to Mantosh, my team, and they will be sharing those things to you guys.
Okay, yeah.
Okay. So first of all, apt update, and then these are dependencies required by your Docker packages. So we need to install them on our server. It is already installed, it's telling me that is done. And we need to add Gpg key here. Add the Gpg key and repository. This is how I'm adding repository there. And then Docker update, and then Docker install.
Anish, I have a question here. What is GPG key that we were?
Yes, sure. It's a part of Linux administration basically. So
Okay.
Gpg key is nothing but a kind of signature that will be added to all RPM, all the packages that you are trying to install over here, right? We added the
Okay.
key first of all on our system, and whenever we will be trying to install these things, it will be checking those keys whether this package is having valid keys or not. If these packages is tampered with the key, it will inform you.
Okay. Yeah.
So are we installing any specific version of Docker, or it is the generic
Latest
one?
version of latest version of Docker we are installing.
Okay. And so is it owned by some specific, so there are some different Dockers available in the market, or it is just a
Different
common?
version will be they are like that I'll tell you. Where is that? See that there are three type of repositories are available. Stable that we already going through with the stable only, and nightly and test. These two kind of repositories are available here. If you want to test something, it is just related to test. Future version will be in nightly, and this is for testing. Might be a few different feature available in these repositories, but nobody will be going through these things because these are on for testing and future releases. We'll have to go in our environment and our project, and we have to work now only. So that is the thing, right, guys? So see this thing here, hub.docker.com, hub.docker.com. Here we can go. So guys, hub.docker.com is a location or a repository where all vendors are uploading their images here. Let's say you want to use CentOS image.
Thanks for watching. Want to study further? Join our training programs today.